Hello, welcome to a fresh homegrown video for 2012 on sections 3.7 and 3.8. So sections 3.7 and 3.8 deal with a lot of stuff, but there's a couple specific things that I want to talk about from each section. Section 3.7, we're going to look at a thing called a determinant. In section 3.8, we're going to look at another thing called an inverse matrix. Let's start with section 3.7. A determinant is simply a matrix operation. So, for example, let's say I had a 2 by 2 matrix and I want to find the determinant of that matrix. And determinant's abbreviated as DET. Well, all it's going to be is just simply AD minus BC. It's just a simple formula. So a determinant is just going to be the product of two of the numbers in your matrix subtracted by the product of another two numbers in your matrix. So for example, let's say you're asked to find the determinant of 4, 0, 8, and 10. Then all you're going to do is you're going to do 4 times 10 minus 8 times 0, which would be 40 minus 0, or 40. So that's all it is. A determinant is just simply a matrix operation. But it's a matrix operation that involves the product of two numbers minus the product of another two numbers in your matrix. Determinant can only be done on square matrices. So what that means is that the number of rows has to equal the number of columns. So you can't do it on a 2 by 3 matrix, but you can do it, say, on a 3 by 3 or 4 by 4. Now you probably ask yourself, okay, what's the point? Why do we need to know this? Or what kind of practical application can I use a determinant for? Well, believe it or not, you can actually use this for geometry. Practical application for determinant. Say, for example, I gave you 3 points. And say we made a triangle with those 3 points. So here we have 0, 0. Here we have 2, 2. Here we have 2, 0. What would the area of this triangle be? If you take some time to think about it, and if you remember from geometry last year, hopefully said the answer is 2. That's because area is 1/2 times base times height. My base is obviously going to be 2. My height is also going to be 2. So 1/2 times 2 times 2 gets me 2. Now how can I use a determinant? Well, area of a triangle can also be expressed like this. Plus or minus 1/2 x1, y1, x2, y2, x3, y3, and actually hold on one sec. It's got to be plus or minus 1/2 times the determinant of this matrix. And the last column will be all ones. So here we have a 3x3 matrix. The 3x3 matrix is designed so that we put in all the x coordinates in the first column, all the y coordinates in the second column, and ones in the third column. Let's actually try this out. Plus or minus 1/2 times the determinant. And the order in which you write your points don't matter. So say we do 0, 0 as the first point, 2, 0 as the second point, and 2, 2 as the third point. So again, all I did was I took the coordinates of the corners, or vertices of my triangle, one of the points, plugged in for x1 and y1, one of the other points, plugged in for x2 and y2, one of the other points, plugged in for x3 and y3. Now, the way you do this in the calculator, because for 3x3, use the calculator for determinant. You could do it by hand, but I only showed you how to do it by hand for a 2x2. And for 3x3, it's pretty nuts. So, here's what we're going to do. Notice how I downloaded this new thing. It's called Wabbit. It's an online calculator. So I'm going to turn it on. Go to second matrix. I'm going to edit that one. I'm going to do a 3x3 matrix. And I'm going to type in 0, 0, 1. Then I'm going to do 2, 0, 1. Then I'm going to do, let me think here, 2, 2, and 1. I'm going to quit. Then when I go back into the matrix, there's a whole bunch of actually matrix operations. We're only going to use the first one here. That stands for determinant. Then I have to go back to the matrix and call up matrix A. So we get 4. So going back, that's going to be plus or minus 1/2 times 4. Now the reason why we have the plus or minus is just in case the determinant is negative. Because sometimes that can happen. And so in that case you multiply by negative 1/2. But because the determinant is positive, we'll multiply by positive 1/2. And of course that gets us 2. So we start dealing with a more complicated triangle like something like this here, where it's not so obvious how to find the area, how to find the base, or you have to use distance formula. It's probably better to just use the determinant here. So you can see how that works. So we'll practice this in class next time we meet. Finally, for section 3.8, say for example you want to solve this problem. So for section 3.8, that involves an inverse matrix. Let me explain. Well, before I explain what inverse matrix is, let me show you the example we're going to solve. Say we had this system of equations here. X minus 3y equals 5, 2x plus y equals 17. Now, if you were to solve it like the way I've taught you with like elimination or substitution, or if you even use a solve2eq program in your calculator, you'll find that the answer will be 8, 1. So I already know what the answer is because I actually designed this problem, so I should know what the answer is. And plus, if you plug in 8 and 1 for both x and y, it works. Well, how to solve using a matrix? Well, here's what we're going to do. We're first going to organize our information into a matrix. So 5 and 17 get their own matrix. X and y get their own matrix. And the coefficients get their own matrix. So if you think about it, this is the coefficient matrix. This right here is the variable matrix. I'm not sure what to call the other matrix, but this is a 2 by 2, and that's a 2 by 1. See how those match up? Plus, if I were to multiply these two matrices together, I would have 1 times x minus 3y, 2 times x plus 1y, which is exactly what I have right there. So you can reorganize your equation into these matrices here. To get x and y by itself, what you have to do is multiply both sides by the inverse of your coefficient matrix. You guys might remember negative 1 power is like when something's flipped over. It's kind of the same thing here, but not really. I know this is a bit complicated because it's the first time you're seeing this. So I do expect some questions, or maybe you could say you were a little confused when you watch the video. But what we're going to do is we're going to multiply both sides by the inverse matrix of our coefficient matrix. Remember, our coefficient matrix was made by the coefficients of x and y. And if you think about anything times its inverse, just goes away. So actually what's going to happen here is if I multiply the inverse matrix by the coefficient matrix, it winds up becoming 1, 0, and 0, 1. And anything times 1 just becomes itself. So if I work out this side, and actually let's do this in the calculator right now. So let's pull up the Wabbit. Go second matrix. Now we got 2 by 2 matrix. And 1, negative 3, 2, and 1. You might want to follow along with your calculator too while I'm doing this. And then we had a 2 by 1 matrix on the right side of the equation, which is 5 and 17. So if I call up matrix A and then take the inverse of it and then multiply it to matrix B, I get 8, 1. And on the left side here, when I multiplied this one and this one together, let me just show you how that looks. If I do matrix A, the inverse, times matrix A, see I get 1, 0. This is called the identity matrix, because anything times the identity matrix will just wind up being itself. Like if I do 1 times x plus 0 times y, that gets me x. 0 times x plus 1 times y, that gets me y. So you see how x and y are both 8 and 1. Now you might ask yourself, well, why not just do this like the way we've done before? Okay, what if I had a crazy equation like 4x plus 8y plus 9z plus 10w equals 156, and say I had a whole bunch of other equations just like that? To do that by hand would be a nightmare. A matrix can actually do that very easily if you organize it into a matrix and then solve for all the variables. So we'll see problems where we can do that in class next time we meet. So we've talked about the inverse matrix. And remember, inverse matrix is almost like matrix division. So kind of like matrix division, but not really. But you're undoing matrix multiplication. So basically it undoes matrix multiplication. And that's kind of the key thing with inverse matrices. And of course, we talk about the determinant and how that works. So we'll talk more about this as a class next time we meet, and we're all done. Okay, that's it.